recording, sharing the screen, stuff like that. Right, so we're on target still to have our exam on Friday, and all the rules that applied last time apply this time. So since you've already had one exam, you know what they're like. Okay, so maybe around 9:01, 9:02, I'll either email you or send on Canvas announcements the exam, but I'll also present the exam here in case some of you can't get that, just to make sure I catch everybody. It may not fit all in one screen, so I'll, do the first part of the test and then the second part of the test. Roughly 10 questions again. So let's see. We only have 4 sections, so that means there's going to be probably 2 questions per section and maybe another from some others. So I usually tend to give about 10 questions, just like the last test. All right, and you submit the homework. There's a 70% requirement. Again, that should not be that hard considering we almost end up doing close to that anyway in class, or a very high percentage of the homework. Okay, so I'll send you the Canvas announcement or email, probably Canvas announcement, 9:01, 9:02, 9:03, something like that. Then you join and just get started right away. I will not call the roll, but I have the whole hour to take attendance. So it's too disruptive, of course, if I call everybody's name. I mean, think of it, we were meeting on campus face-to-face. On an exam day, I wouldn't call attendance. I would just look, and I got the whole hour to do that, right? So then what else? Show me your camera. Okay, so I need to see you, see your work. I need to see your actual face and your work and what your surroundings are like. So again, no special background. Please let me see the actual background. And then when class is over at 10 o'clock, I turn off the meeting, and then you have 5 minutes. So what, 10:05? You have to take a picture of all your work. So click, 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 click. Or if you have a scanner like Cam Scanner, that would work even better. And then send that to me email. So you have until 10:05 to submit the test, actual test, and then you have until 10:30, so half an hour to turn in the homework by 10:30, since that might be longer. If you want to submit the homework earlier, that's fine. And yeah, some of you were noticing this. I was noticing that you probably can't get all the homework maybe in one file because it's too big, or maybe not even one email, because there's how there's a certain limit to how much you can send on one email. So once you surpass the limit, sometimes it doesn't work. So you might have to send 2 or 3 emails for the homework. I don't mind. Some of you sent 1 per section, like you submitted 2.2 and then the 2.3 and then 2.4 and then 2.5. You can do that. That's fine if you don't think it's all going to fit in one. I think everybody submitted something that I eventually was able to open. I'm trying not to do anything too funny or esoteric. I know I can open PDFs. That certainly works. But any fancy stuff like zip files, I'm not sure I can get zip. It kind of depends. Sometimes I can get it, sometimes I can't. But yeah, you notice sometimes the homework, I wasn't able to all get it, or you had to break it up into pieces. So, that's fine. And that's the reason why I'm giving you another half an hour to submit the homework. Okay. You get your cheat sheet. So one of these, front and back. You don't have to submit the cheat sheet. So some of you are submitting it. I don't need it. You can just keep it. Put anything you want. Formulas, sample problems on your cheat sheet, front and back, but you can't use anything else. So no other books or no extra notes. You can't use people, of course. You can't use a computer. Look stuff up. And that's why I need to see your camera so I can see you working. All right. And those are the main ideas. You can have a calculator, naturally. Show all your work. Everything show as many details as possible. I do give partial credit. I think I've mentioned this before, but you can actually get more points with an incorrect answer, but you show me the work, than if you got a correct final answer, but you didn't show me any work. I might not give you very many points for that at all. All right, so show all your steps, show all your work. I can follow your logic. In case the calculation goes wrong somewhere, I can very easily make a calculation error also. So it's in your best interest to show me as much work as possible. Okay? If you just show me answers and there's no work, that's a good time for me to suspect cheating, right? That somehow you just got the answer, but you didn't show me how you got it, right? Okay, and reminder, this is all messed up now. It's on the recording also, but anyway, so 2.2 is now 1 to 25 odd. 2.3, the easiest way I can explain it is it's still 1 to 21 odd, but skip 7 to 19, which means we're throwing out a lot of it. Okay, and 2.4 is now 1 to 21 odd. 2.5, 1 to 6 all. 7 to 35 odd, skip 15 and 17. Okay, and a lot of this was because I shortened the assignment because I had no internet last week, so I said, okay, what can I trim? What topics can I trim without compromising too much? And so that's what I decided on. Okay, so that's what we got for the exam. All right, so if anybody has any questions about that, I'll save it for the end. I do want to get to lecture right now, and you may have questions about the exam and so forth. And yeah, I hope to actually finish 2.5 today. I'll either finish or come very close to finishing, and then I'll take tomorrow to finish it up and take questions. So when you come in tomorrow, you may ask any questions from this stuff. Again, I prefer not to take questions outside of the actual homework. All right, I may decide to say, no, I don't want to do that because it wasn't assigned. Okay, but if you don't ask me stuff, I may just go ahead and get started with chapter 3. Okay, so again, your strategy, if you don't want me to go on and do new stuff, which I don't have to, then ask me lots of questions for tomorrow in preparation for Friday's test. Okay. All right, so that takes care of that. Now we'll start. Okay, I'm actually going to go back and do 2.421. Okay, so the last question, 2.4 from 21, and it was based on this graph. Unfortunately, the questions are up here, but then you have to go back here. So I wrote it on a piece of paper here. Hopefully I can show you both at the same time. So yeah, I think I can get that right here. Okay, so these questions that are up here, I've got it on paper. Okay, so not to worry. So let me keep this picture right here. So you have the red function, g, looks like it's a straight line, negative slope. And then you have the blue function, f. Okay, it looks like it might be a polynomial. We'll do polynomials in the next chapter. Okay, so for 21, number 1a says f of g of -2, fog f of g of -2. So it's f of g of -2. So by order of operations, you do g of -2 first. So for the g function, okay, which is the red, g of -2, g of -2, 1, 2, looks like it's about here. So where's here? Looks like it's about 1. Okay, so this thing right in here is 1. G of -2 is 1. Right there, when x is -2, y is 1. And now I take that and apply it to f. So now I want f of 1. So blue graph, f of 1, I go to 1. The y value is up here. So where's here? It looks like it's 2. Okay, so f of 1 equals 2. Second part, they reverse it. Goff, g circle f of -2. And again, I want to emphasize, you say, are these always going to be the same? The answer is no. F circle g and g circle f are not going to be the same in general. They might be sometimes, but not always. Okay. The language we would say is that they're not commutative. You don't have to write that down. Commutative means you can switch the order and you always get the same thing. Addition is commutative, right? 5 plus 7, 7 plus 5. Multiplication is commutative. Right? 5 times 8 is always the same as 8 times 5. Okay? But subtraction is not commutative. Right? 10 minus 13 is not the same as 13 minus 10. And division is not commutative. Right? 4 divided by 2 and 2 divided by 4 are not equal. Okay? So it turns out this composition of functions is not commutative either, as we shall see. All right, so g circle f means g of f of -2. So when you see this Goff or fog, interpret it like so. Again, if you want to put it on your cheat sheet, you may. So I'm supposed to do f first. So even though they write it like Goff, you actually do it from right to left. You do the f and then the g. So it's actually kind of going this way. So f of -2. So -2 for the f function, the blue one, is 0. Okay, so I'm doing g of 0. So now for the g function, when x is 0, what's y? Well, it's also 0. So g of 0 is 0. So the answer to II, number 2, is also 0. Okay, the third one, g circle f of 2, golf of 2, g of f of 2. So by order of operations, you do innermost first, f of 2. Or think of it as going from right to left, not left to right. Right, f of 2. So f of 2, 1, 2, on the blue function, it's 0. So right in there is 0. So I do g of 0. Oh, we just did that. G of 0 is 0. It touches the origin. So once again, the answer is 0. So by coincidence, these two are the same, but we can't always bank on that. All right, then finally, fog f circle g of 2. It means f of g of 2. So first I do g of 2. So red graph when x is 2, what's y? So x is 2, y is down here, whereas here, it looks like it's negative 1. Okay, so I'm doing f of negative 1. All right, so now f of negative 1, blue graph. Blue graph when x is negative 1, here it is. What's the y coordinate? So it looks like it's down here. So where's here? Negative 2. All right. So that's part A. Okay, then part B is a little bit more tricky. Determine all values of x that satisfy the equation. So f circle g of x equals 0, g circle f of x equals 0. Okay, so how do you do that? Here's a graph. Yeah, I think I can do that. Okay, number 1, f circle g of x equals 0, fog of x equals 0, f of g of x equals 0. Okay, and this is, again, one of those situations where I think if you don't like looking at something, don't look at it. Let me just cover it up. F of something equals 0, right? Whatever is behind the pen. Okay, so f of whatever equals 0. Okay, let's look at the graph. The blue graph, with the blue graph, f of blah, blah, blah equals 0. Remember that saying y equals 0. So for the blue graph, where is y equal to 0? I have 3 places, here, here, and here. So where are they? Negative 2, 0, and 2. So that means if behind my pen, right? Right now it's a mess, but if behind my pen were equal to negative 2, it's true, because f of negative 2 is 0. If I had 0, it's true, because f of 0 is 0. And if behind my pen it was a positive 2, I would also have 0. Right? So the thing behind my pen, there it is, g of x, can be either negative 2 or 0 or 2. It's a little bit tricky. So one more time. Behind my pen, if I had negative 2, it'd be true. I get a 0. If behind my pen was a 0, it would be true. And if I got a 2, it would be 0. So what is behind my pen? G of x. So that g of x, you want it to be negative 2, 0, or 2. Okay, and of course now when I write g of x, that is the y coordinate. The y coordinate for the red function. So now I look at the red function and say, when is the y value of each of these guys here? Okay, so y equals negative 2 for the red graph. So red graph, y is negative 2, it's over here. So where's here? Well, they don't put it, but it looks like to me it's about 4, right? If you look at the pattern, it goes 1, 2, 3. So that looks like it's negative 2. So I'm going to say 4. So x is equal to 4. Okay. And then when is g of x equal to 0? Well, that's right at the origin. That gives me 0. And when is g of x equal to 2? The y coordinate for g is 2, the red graph. So when's the red graph 2? That's way over here, right? So there's y equals 2. It's right over here. So where's here? Again, that's off the mark, but I'm going to say that's negative 4 because they show me negative 1, negative 2, negative 3. So that looks like it's going to be negative 4, right? So my final answers are 4, 0, and negative 4. A little bit tricky. so again, the logic, think of f of g of x equals 0. I kind of cover that up and say to myself, okay, when is y equal to 0 for f? At -2, 0, and 2. So behind my pen, g of x can be either -2, 0, or 2. So now I find the corresponding x values for g of x. So the y coordinate for the red graph, g is red. I want y to be -2. That's an x of 4. I want y to be 0. That's an x of 0. And I want y to be 2. That's way over here. Where's here? -4. Okay. And finally, I'm doing B part 2. G circle f of x equals 0. So I kind of do the same thing. G of f of x equals 0. So again, I just kind of cover it up. G of what number equals 0? So red graph, when is y equal to 0? Only at 0, right? G of 0 is 0 and nowhere else. G of 1 isn't 0, G of 2, G of -1, they're not 0, only G of 0 is 0. So behind my pen needs to be equal to 0. Behind my pen, f of x is equal to 0. So now I say f of x is 0. That's like saying y equals 0, blue graph. So when is y equal to 0, blue graph? Well, we just did it here, here, and here. So -2, 0, and 2. -2, 0, and 2. All right, so that does it for 2.421. Okay, and now I'll go back and do stuff from 2.5 once again. All right, so I did 2.5 yesterday, and I'll do a lot more. Just rehashing some stuff here. Determine whether these are functions. Some of these I just talked about it quickly, but I'll do more of it here. So is it one-to-one? Okay, so remember, for a one-to-one function, it has to pass both the vertical and horizontal line test, right? So number 1 is one-to-one. Number 4 is also one-to-one. Number 5 is not one-to-one. It does not pass the horizontal line test. Okay, so it's knowing something about the graphs. Okay, so I rewrote it, or I wrote it earlier better. Number 7. I think yesterday I just alluded to it. But f of x equals 3x minus 4. For this one, you don't need an exact graph. You just know slope is 3, y-intercept is -4. Very crudely, it goes something like this, right? Positive slope goes up, y-intercept is negative. Okay, so does this look like a one-to-one function? Yes, it is. It passes both the horizontal and vertical line test, right? If I draw both vertical lines and horizontal lines anywhere, it touches at only one point. So it is one-to-one. Okay, 9. Again, I alluded to this yesterday, but a little bit more accurate here. F of x equals absolute value of x minus 1 plus 1. Okay, you should be comfortable with a quick and dirty graph of absolute value. It's V-shaped, goes through the origin, goes like that and like that. So the red graph is absolute value of x. And then we translate it, right? Translate means to move. This means 1 to which direction? 1 to the right and 1 up. So 0, 0 moves over to 1, 1, and then you just draw the same general shape. So this part actually just lies on the same line there, but this one comes over here. All right, and is this one-to-one? Certainly not. Right? I draw a horizontal line right there. It's going to touch at 2 points. So it's V-shaped, so this is not one-to-one. And yeah, while I'm at it, go back and re-emphasize the translation rule. It was the first topic of chapter 2. And I gave you that last week, at least I tried to when my internet was out. It's even back in 2.1, which had no problems, but it gave you the principle on page 84, right? You can put this on your cheat sheet if you want. The blue is always the given function, f of x. F parentheses x plus c C units to the left. F parentheses x minus C units to the right. If they write it like this, f of x plus C is outside the parentheses. That's C units up. And f of x minus C outside the parentheses, C units down. And so I applied that in this case. So from here, this tells me automatically take the absolute value function, move it 1 to the right and 1 up. Okay, 11. X to the fourth plus 1. Now, x to the fourth kind of looks like x squared. I mean, it's a different graph. We don't call it a parabola, but it still kind of goes up. Okay? And then the plus 1 moves the whole graph up 1. So it looks something like that. And you can see if I draw a horizontal line right there, it touches more than 1 point. So number 11 is not 1 to 1. And once again, here was 13. Quick and dirty graph. 2x squared, right? You should know x squared. 2x squared just makes it steeper. So it's still going to go up something like that. It includes 0 because I have the line underneath the 0 here. So closed circle right here. Open circle here. So x is less than 0. For this part of the graph, if I plug in 0, I get -2. So open circle at -2. Slope is 1. That means it's going up at a 45-degree angle. So something like that. And you can see this function is 1 to 1. If I draw a horizontal line anywhere, it's going to touch in 1 point at the most. Okay, the rule is at most 1. You don't have to touch everywhere. Like if I draw a horizontal line right there, it looks like it touches 0. Is that right? That's okay. As long as you don't touch 2, it's 1 to 1. So if I go like that, touch 1, touch 1, touch 1. Right here, I touch 0. That's okay. And touch 1, touch 1. As long as you never touch 2 points or more. So it's considered 1 to 1. All right. Now I have this. Again, I'm not going to wait for you to write it because I've said it. It's in the book, and you can look at the video. But 1 to 1 functions have inverse functions. Okay? Only if a function is 1 to 1, passes both the vertical and horizontal line test, you have something called an inverse function, and here's how you write it. Looks like f to the -1 of x, but we say f inverse of x. This is the inverse function. Okay, and inverse function has these properties. Again, you don't have to write it down. You can if you want to later, but sorry, I'm not going to take the time for you to write it all down. You can watch the video later, and it's in the book. But f inverse, that -1, has a property that f circle f inverse of x is equal to f inverse circle f of x is equal to x itself. Okay, so if you compose f with f inverse or f inverse with f, you always get back the original. It's sort of like the undo function. F inverse is the undo function of f. You know, even on your computer, right? Sometimes you make a mistake and you say, oh, I made a mistake. Can I get back to where I just was? That's an undo function. Some applications, the shortcut is Control Z. If you've heard of Control Z on your calculator, your computer, sometimes I mess up. And then, oh, can I get back to the previous step? A shortcut is Control Z. That brings you back to where you were, right? That's the undo function. So F inverse is the undo function of F. Okay. Now, to get the inverse function, switch every occurrence of x comma y to y comma x. And we've already talked about that, right? Change x to y, change y to x. Okay, so that means if 3 comma 5 is in F, 5 comma 3 is in F inverse, and so on. Okay, so every ordered pair in F, just switch them around, and you have an ordered pair in the inverse. So if 3 comma 5 is in F, then 5 comma 3 is in F inverse. And we talked about this before also. The domain of F becomes the range of F inverse and vice versa. Okay? Just take the domain and range of F and switch them around, and you have the domain and range of F inverse, which makes perfectly good sense because you're just switching around x and y. So the domain of one becomes the range of the other function. Okay. All right, so that's that. And now I want to do some of the problems at the end. And after I finish that, I think I'm done. So, all right, so we did these. I've done these now. And I showed you enough of these. I showed you some of these, and I'll do more of these. Okay. So again, about the 70% rule, it looks like I've done 70% or even more just by myself. So it should not be that hard to pass the 70% rule, because I've done either 70% or very close to it anyway. All right, so I showed you some of these yesterday, and I'll do more. Okay, so find the inverse function and graph f and f inverse on the same coordinate axis. Okay. So here's problem 33. F of x equals 1 plus x cubed. Okay. Now, you should know something about the graph. Okay. Do you remember the graph of x cubed? X cubed is a cubic. And then the plus 1, whoops, plus 1 just moves the graph up 1 unit. So there's x cubed plus 1. So x cubed goes through the origin. X cubed plus 1 goes up. Yes, you can always plot some points. And I plotted a few points here, but anyway. So how do you find the inverse? Call f of x, y. And then you switch x and y. We did that yesterday, right? So switch the x and y. Everywhere you see x, put y. Everywhere you see y, put x. So instead of y equals 1 plus x cubed, x equals 1 plus y cubed. And now algebraically solve for y. Right? So how do you get rid of the 1? Subtract 1. Right? So you have x minus 1 equals y cubed. X minus 1 equals y cubed. How do you get rid of the cube? Cube root. Right. Usually when you solve here, the y ends up on the right-hand side, but by tradition, we put it on the left. So now y equals f inverse of x. I want you to show me that you know this notation. So on the exam on Friday, if I ask for the inverse, you need to show me this f minus 1 x symbol. Okay? Don't just leave it as y. I'll take off points for that. Okay? So put f inverse of x equals cube root of x minus 1. All right, so how do you graph the function in its inverse? Well, we know what x cubed looks like, so x cubed plus 1 goes like so. Okay, and one thing you can do is just plot some easy points, like what do you get when you plug in 0 right here? You get 1, 0, comma 1. What do you get when you plug in 1? 2, 1, comma 2. What do you get when you plug in a 2? 2 cubed is 8. 1 plus 8 is 9, so 2, comma 9. What do you get when you plug in negative 1? Negative 1 cubed is negative 1. 1 plus negative 1 is 0. So negative 1, 0, 0, 1, 1, 2, 2, 9. All right, now, how do you graph the inverse? You could graph this by plotting points, but an easier way to do it is once you have these points, just switch them around. Okay? So if you switch around 2, 9, you have 9, 2, which looks like that point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. The point 1, 2 becomes 2, 1. 1, 2, 1. There it is. Switch around 0, 1. 1, 0. There it is. Switch around negative 1, 0. 0, negative 1. There it is. So like the red one, so I plot them, it kind of looks like that. So there's the inverse function. Okay, so the blue graph is the original function, and the red is the inverse function. Now, it didn't say to put y equals x, but I put it anyway. So in the directions, let's see. It said graph f and f inverse on the same coordinate axes. Okay, I did it. But it might say graph the line y equals x also. So if it says it, do it. And if it doesn't, then leave it out. Okay? But I put it in. And so the idea is that y equals x is the reflection, right? The reflection line. So the reflection of the blue is the red, and vice versa. Okay, so if you bounce this thing off the mirror, it gives you that branch. And if I did it with 100% accuracy, if you bounce that blue part correctly off of the mirror, then it ends up being that part over there. There we go, y equals x. All right, then 35, and then I'll be done. What time is it? Not even 9:45. Okay, we might end a little bit early, folks. So if you have a pressing question after I'm done in about 5 minutes, you can ask it. Otherwise, we're done for the day, and we're done for the chapter. 37, skip. Okay, so I did it last time I taught the class, but we're skipping that. Okay, f of x equals x squared plus 1. X is greater than or equal to 0. Okay, let me talk about that just for a moment. Okay, now you should be somewhat comfortable with x squared. What is x squared? It's your basic parabola, right? U shape. I know, I can do a quickie graph like that. And what about x squared plus 1? I take this graph and move it 1 unit up. So it goes up 1 unit. So this x squared plus 1. Now you look at that and say, hey, that's not 1-to-1. It does not pass the horizontal line test. Okay, true. But they said x is greater than or equal to 0. So if x is greater than or equal to 0, I only have that part. Okay, I don't have anything in the second quadrant, just the first quadrant. And if I take only that piece right there, now is it 1-to-1? Yes, it is, right? So that's why they had to restrict the domain. If you throw out the negative part, let x only be greater than or equal to 0, now you have a 1-to-1 function, which means now it has an inverse. Okay, so find the inverse. Call that y. Y equals x squared plus 1. Switch around x and y. X equals y squared plus 1. Solve for y. So take away 1. X minus 1 equals y squared. Take the square root. Normally, you would say plus or minus. Since we only want x is greater than or equal to 0, I only want the plus. So y equals square root of x minus 1. That's my f inverse of x. So the f negative 1 x, we say f inverse of x. And there it is. Okay. And let me do that just by a translation and moving. So you should remember square root function. Right? So the square root function looks like that. And if I replace x by x minus 1, all under the square root, that moves 1 unit to the right. So here we go. Goes like that. And we can check a very simple point. What is this point right here? Looks like it's 0, 1. By the way, what do you get when you plug in 0? 1. Switch around 0, 1, and you get 1, 0. Check, what do you get when you plug in 1? 0. Definitely works. Okay. And just for practice, how about that point over there? That looks like a 1, 2. So this should be 2, 1. And so on. And we can check by formula 1, 2. What do you get when you plug in 1 over here? Right? 1 squared is 1, 1 plus 1 is 2. So in the inverse function, when I plug in 2, I should get 1. Is it true? Plug in 2. 2 minus 1 is 1. Square root of 1 is 1. So yes. And then all the other points. Okay, so here's the function. Here's the inverse. And once again, here's the line y equals x. So you can see the green is the mirror image of the red. The reflection, formal language, the reflection of the green graph across the line y equals x is the red graph, and vice versa. And there we go. All right, folks, I'm done with lecture. In fact, I think I'm done with the entire chapter. So let me stop the share. Okay, so the last 10 minutes, if you want to ask questions, you may. Let me double check the chat. Okay, 2.5. Okay, so 2.535, step, I think we just did that, right? Okay, so yeah, I got that. So I think I'm up to date with the chat. All right, so last few minutes, does anybody want to ask me stuff?
Professor, I have a quick question.
Do we need to draw out y equals x when graphing the inverse? If it says so. Okay, so if it says graph it, then go ahead. If it doesn't say it, you don't have to. Well, let's just say you're never wrong in doing it. I'll never take off points if you decide to draw the line y equals x. Okay. All right, so anybody else with a question for the last, what?
Yes, Professor.
You can either unmute. Yes, Madeline?
So for the inverse questions, do you want us to write the answer as y equals f inverse and then the function, or is f inverse and the function fine?
Okay, so do we have to write y equals f inverse or just write the f inverse? You can just write the f inverse, although you kind of have to write the y anyway to show that you're solving for y. But yeah, your final answer, you can just write f -1 x equals blah, 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 blah.
Okay, thank
But
you.
if you want to write the y, no harm. Okay. All right, and let's see what else in the chat. That's it. And if anybody still has any general questions about the test, you all saw the first test, so you know the ground rules. If anybody want to rehash anything there, you may also. But now that you've had one test, you know what they're all like. I want to see your actual face, right? Have yourself muted. During the test, if you have a question, please just type it in the chat. Don't, you know, unmute yourself and blurt it out. Just think of what happens if we had a test and we were meeting face to face on campus, right? You wouldn't just shout out during the test, "Hey, teacher, what do you do?" You know, whatever. You know, you would come up to me privately or ask silently rather than just shouting it out. So yeah. Okay. So anybody else with anything? Because if not, I got nothing. We can stop. Again, if I miss you for the attendance, just send me an email and that'll be fine. Anybody else? Otherwise, we can end. Okay, so again, tomorrow, it's your time to ask me any and everything from chapter 2. And especially you might want to ask those early sections because of last week, I didn't have any internet access, so I kind of changed that. So tomorrow, ask me anything you want, but if you don't ask me stuff, I will threaten, I don't know if threaten is the right word, but I'll threaten to get started with chapter 3. So if you don't want me to do that, I'm okay otherwise by just taking all questions for tomorrow. And then Friday will be the test. So same rules, you submit the homework on Friday, and you know the rules about when you have to turn it in, good stuff like that, okay? Anything else? All right, we're done, folks. All right, so that'll do it for today, and have a good day, and we'll see you tomorrow. Thank you.